The solar system and universe have distinct properties that have been investigated and quantified by scientists for many years. Today, I will be talking to you about supernovas.
A supernova is a massive explosion generated by a dying star. It is the largest explosion that takes place in space. Typically, a star will go supernova approximately once every 100 years in a galaxy the size of the Milky Way. A star explodes every second or so, somewhere in the universe, and some of those aren't too far away from Earth. Only a select few stars become supernovae. Many stars cool in later life and die as a white dwarf star. Others turn into black holes. When a supernova occurs, matter is sent flying into space. When supernovae explode, they send matter into space somewhere between 15,000 and 40,000 kilometers per second. When this happens, it can shine as bright as a galaxy for short periods. Stars are like massive nuclear reactors. A star produces energy by fusing hydrogen into helium. Eventually, stars run out of hydrogen to fuse. When this occurs, a star then fuses heavier items like helium into iron. When this happens, a star's core begins to get smaller, while the outer layer expands. As the outer layer expands, it can even consume other planets. When the star runs out of helium, fusion just ends. If it's a small star, it becomes a dwarf and just fades away. However, when a large star exhausts its helium supply, the core collapses immediately and reaches unbelievably hot temperatures. Scientists believe that a star gets as hot as 10 billion degrees Fahrenheit. The outer layer of the star also collapses into a massive outward explosion. This is known as the supernova. These enormous blasts release many of the elements in the universe, including some elements like iron, which make up planets. It is hard to believe, but true, that all of us carry the remnants of these distinct explosions within our body. Supernovas generate enough energy to fuse elements heavier than iron. Elements with high atomic numbers, such as gold, silver, and uranium, are created. Scientists have determined that supernovas play a key role in distributing elements throughout the universe. What is left of the star's core becomes either a black hole, which contains such densely packed matter that not even light can escape the gravitational pull, or the core becomes a condensed neutron star. After a supernova occurs, material expelled in the explosion may form nebulae, which is a massive interstellar cloud of gas and dust. Over millions of years, gravity pulls nebulae material together into a hot, dense core called a protostar. A protostar, after time, becomes a newborn star. The new star's gravitational effects on the surrounding nebulae material may form comets, asteroids, or even a new planet. This is the cycle of a star. A supernova burns for only a short period of time, but it can tell scientists a lot about the universe. The aging of stars and their transformation into white dwarfs, black holes, or the exploding supernova has shown scientists that we live in an expanding universe, one that is growing and constantly changing. The Canadian Space Agency is not as well funded as other countries' agencies. For example, NASA in the United States is one of the world's leaders in space exploration and research. However, Canada does partner with the US and other countries to support research around astronomical events. Canadian research in the field of cosmochronology, which helps age the star in the universe, is leveraged by many countries when researching nebulae and potential supernovae. Since all stars have a finite amount of fuel, an appropriate question is, how long will our sun shine onto Earth? Scientists believe that stars like our sun burn for about 10 billion years. Using cosmochronology, scientists have determined that our sun is between 4.5 and 5 billion years old, so we have about 5 billion years to go. But know that our sun will not become a supernova. Based on the size of our sun, it will become a red giant. It will get bigger and cooler over time, but no one here will have to be concerned about that.